show what they know. They can't sort of sit in the back of the class and get a D- and
Right.
go on. So it's good because it really feels like it holds me accountable to teaching them stuff, and it holds the kids accountable to learning.
Yeah.
So I think it's a much better system than grades.
Yeah.
And we have we're a trauma-sensitive school. We have a lot of social-emotional support. We have an advisory system where I'm really on top of my kids to make sure they're coming because attendance is a big problem.
Yeah.
And that they're graduating.
Yeah. And is it like 9 through 12, or is it
it's
some
16
other...
to 22 years
Okay.
old. Yeah.
Okay, cool. And so, like a student, like, do you teach like the normal, like, this is algebra class, this is geometry class, or is it some other like, individualized program or something like that?
It's relatively traditional, but we break into trimesters. So, for example, I teach function families, which is like linear, quadratic, and exponential functions in one trimester chunk.
Okay.
And then I teach coordinate geometry, which is just a third of the geometry curriculum in one chunk.
Okay. So, okay, yeah. Before you were doing that here, so I guess... What other, so you said you taught function families and coordinate geometry. Are other classes you taught while you've been here, or just those two?
Just those two. Oh, and then we have a thing called Project Month, where for 1 month, kids do an interdisciplinary project, and they take that one project all day. And so I taught statistics combined with an English teacher. And we looked at schools and like what makes a good school. That was the project.
Okay.
Yeah.
And then what about, like, before coming here, what other classes have you taught?
I taught geometry.
Just geometry? Okay.
Both those 2 years.
Yeah. I miss geometry.
Yeah.
I taught geometry when I was teaching.
Nice.
It's fun.
Yeah.
And what about the students who end up here? So you said it's like a model for, students who haven't been successful elsewhere. Like, who are they?
Yeah, so there's a really wide variety of students.
Yeah.
Most kids have a lot of stuff going on in their personal lives.
Sure.
So we have some kids who are teen parents. We have a lot of kids who have to do work to support their families at home, so they have to have an adjusted schedule.
Yeah.
Students with mental health issues, students who maybe have IEPs that were never diagnosed.
Yeah. Okay.
A huge range of reasons why kids have this school.
Yeah. This sounds so interesting to me. I was interviewing another teacher in Nashville who was at a similar kind of program where it was for even older students, like for 18 to 23 or something like that. But theirs was like purely like a credit recovery program where the kids were just coming in, and he would do like these 10 to 15 minute mini lessons, and then and then like put kids at a computer, and they would just like work through some computerized curriculum.
Yeah.
And like on the one hand, like that seemed like it was filling a need, because he was saying that the kids who were coming into their program were not sounds like very different from what you're describing. Like what he described was students who, like, in general, their high school career was fine, except like maybe a family member died during this one semester and they failed algebra, but everything else was okay.
Yeah.
So they just need to like come in and like do this one little thing.
Yeah.
Which like that feels like important too, right? Like, why should a kid not graduate from high school because he had this like one thing? Mm-hmm. This seems different and equally important.
Right.
Yeah.
Right. We do a lot of like project-based learning. They just sent me to a conference in Napa about project-based learning.
Napa.
Yeah, which is
nice.
amazing. Yeah, really fun. And we have Project Month, and we try and do more interdisciplinary stuff to be more engaging. We don't have any online classes.
Yeah.
Though we put our materials online so that kids, because of absences, can stay on track.
But kids aren't like sitting at a computer watching a video.
Right. No.
Yeah.
Yeah.
Cool. Awesome. I'm sure we could talk at length about it, but we'll dive right into this. Okay.
Great.
Okay. Here's the first one. I'm sorry that it printed out really small. Not the rest of them are not that small.
Okay. So do I need to read the whole thing?
Yeah, you can just read like the initial scenario.
Okay.
Yeah, that's sufficient. It just is so that when we go back and listen to the recording, we know which item you're working on.
Got it. Okay. Consider the following formal definition, given that n can be what?
Natural numbers.
Natural numbers. Coefficients a sub I can be all real numbers, and a real variable x, then a polynomial is any expression of the form. The sum of, should I say all that? The sum of all numbers from I to 0, minimum 0, maximum n, the sum of a sub I times x to the I power.
That's the most notation you'll have to
Okay,
read all
great.
day.
Gotcha. Which of the following informal definitions of a polynomial is equivalent to the formal definition? Choose all that apply. Okay. I'm supposed to think out loud.
Yeah.
Okay.
If you want to read and have some silent think time, that's fine too.
Okay.
Whatever you
yeah,
prefer.
let me think for a second.
Oh, let me text my colleague to just
Oh,
let me
yeah.
know that I'm going to be a little late.
Okay.
So I see you circled D.
Yeah.
Do you want to tell me why you chose D?
Yeah, well, D's just like straight up translating this
Okay.
sum into like spelling it out basically.
Okay.
Showing examples from 0 to n.
Okay. So D is in. Have you ruled out some of the other ones, or are you still kind of thinking
Well,
about them?
I'm just thinking, okay, what it means by equivalent in the question, because C is sort of like an informal way, like it's giving one example of a polynomial is any expression like, but
Yeah.
I think that's not really equivalent because that can lead to misconceptions, like
Sure.
a polynomial has to have 3 terms,
Right.
or it has to be in this order, for example. So
Sure.
I don't think that's the best answer.
Okay. So are you kind of are you ruling that one out, or is it still maybe on the fence?
I guess, yeah, I wouldn't say that is
Okay.
equivalent.
Okay. So C is out.
Yeah.
Okay.
But it's not like 100% wrong. Also, B, I think B is sort of similar to C. Like, it's a true statement about polynomials. They do have many terms, but it doesn't really say like how these terms are related to each other. Like, that could include division. I feel like a term could include something that would not fit the definition of a polynomial
okay.
based on what this is saying.
Okay. Like a rational term or something like that.
Right.
Like 1 over x.
Right,
Yeah.
exactly, yep.
Yeah.
So, A, I was thinking about it, I was like, but it actually sort of makes sense. Like, that sort of just is what a polynomial is. Right now I'm thinking of like, counterexamples to this. Like, is that actually... There could be division, just not like 1 over x, but like you could have like 2 over 5. That's technically division. I mean, however you interpret a fraction. But I sort of like. Also, what do they mean by multiplication? Because this could be multiplication, for example. Wait, that would still be a polynomial. Let me think of an example. Is there an example where there's multiplication, but it wouldn't be a polynomial? Oh, like, if there was multiple variables, like, that would still be a polynomial. Well, that's not fitting this definition. Is that still... I don't know. Would this be considered a polynomial? Am I allowed to ask you those questions? I think so. Yeah, that is. But it wouldn't be fitting this definition.
Sure. Yeah.
Okay. Given. So I guess I don't know how specific to be. Like, this is saying that there's only one variable.
Yeah.
And including in this definition, there could be more than
Yeah.
one variable. I don't know if that means that it's equivalent or not to And then this is like an extrapolation, but it's not directly saying what that is. I'm
Okay.
just going to say D, but maybe I'm
Okay.
not thinking as widely.
No,
as
that's
I should
okay.
be.
Like, so I'll just ask you
Yeah.
clearly, like,
Yeah.
if you're going to rule something out, it's
Yeah.
just helpful for us when we go back and
Yeah.
look at it that you like you've done with these others
Yeah.
to just cross out the letter.
Oh, sure.
Yeah.
Okay. Wow.
Okay, so for A, let me just make sure I was hearing you correctly. You're thinking about this counterexample that is like a polynomial in more than one variable,
Yeah.
and that's an example of a polynomial that kind of gets admitted by the definition in A that doesn't get admitted by the
Yeah.
definition up here. Is that right?
Yeah.
Okay. And then for option E, what I heard you say was that this is more of like a property or like a something that follows from the
Yeah.
definition.
Right.
Is that right?
Yeah.
Okay.
Well, I want to know the right answer. Whatever. Find out.
Ask me at the end.
Okay. I will.
Okay.
Great.
Any other thoughts on this one?
No.
Okay.
Oh, nice. This is all I teach. Okay. Simona, a student in Miss Shalaby's class, defines a function as where an x is paired with a y. Miss Shalaby wants to help Simona revise her definition and generate the following example. Do I have to read this?
No, that's
okay.
fine. Yeah.
Which method is likely to motivate? Okay. Okay.
So I see you circled
Yeah.
A and C.
Yeah.
Does that mean you've ruled out the other choices?
I'm still thinking about B,
Okay.
but not F.
So why don't we just start at the top?
Sure. Okay. Yeah. So, well, I said A because, map in which elements of the domain are mapped to elements of the range. Like it's not just a pair where order doesn't matter. It's like if I reverse the numbers in this, for example, then it wouldn't be a function. Like if it was -4 and 3, no, this isn't a function, but if it was -4 and 3 mapped to 2, that would still be a function. So that's an important element. And that's also what they talk about in C, that it's not, right, it's not just a pairing. Domain has to have unique values, unlike this example.
How do you interpret this clause about the particular manner?
Our definition to account for the particular
That's been and the reason I
yeah.
ask is that's been a clause that has pulled other people
Yeah.
up short. They've read that and said, I don't really know what that means.
Yeah.
So I'm curious. I'm just curious how
Yeah.
you interpreted it.
Well, it's just what makes a function versus just a relationship. Like this is, she's just describing a relationship. So I think what I interpreted this as meaning like, basically what's the particular definition of a function?
Okay.
What's unique about a function?
Yeah. And how do you see, like, what evidence do you see in Miss Shalaby's choice of example that made you think that this is a thing that she was attending to?
Oh, because this is a example where this fits the student's definition but isn't a function.
Okay.
So it's like what makes this, it's a relationship but not a function.
Yeah,
So what's
okay.
unique about it?
Okay, cool. So that helps me understand you're thinking about A.
Yep.
You kind of have a question mark on B.
Well, then I just started to overthink it. But a function, the word always, function always map elements in the domain with elements in the range. Like, I guess that's how we think about it, but I was trying to think, you could think about a function in terms of, like, I guess we define a function in terms of how elements in the domain map onto elements in the range. But it's not that functions always only map them in this direction. Like, you could think about, there could be some like examples where it would make sense to think about the inverse, but
So is
maybe I'm overthinking it.
is
Yeah.
the thing that you're kind of thinking about is this business of like always mapping?
right. If it was like to point out that we define a function by looking at like more like A. I'm just trying to think what's the difference between A and B. Like, what is it saying differently in
Yeah.
B than A?
What if
Maybe I'm
B had
overthinking it.
said something like wanted Simona to refine her definition to point out that functions map elements in the domain onto elements in the range.
Oh, then I would
or something like that.
Then I would circle that.
Then that would be okay.
Yeah.
And why does this counterexample help you? Why would this counterexample help Ms. Shalaby make progress on that?
Because there's arrows. So they're talking about that 2 is mapped to -4 and 2 is mapped to 3. And if it was reversed, like I said, then it wouldn't be a function. So that directionality is important.
Okay. And like, is the diagram helpful here too, in the sense that she's like drawn out a domain and a range?
Like a specific example.
Yeah.
Yeah.
Okay. Okay. So with that kind of like potential revision,
Yeah.
B is in, but as it's written now, you're kind of like, it's not.
I think so, but I'm not sure if I'm overthinking it. or
Okay.
not.
That's
yeah.
okay. And then you circled C.
Yep.
Okay. So why is C in?
Okay, so I think there's 2 qualities of functions that Simona's not saying that this example shows. One's what's in A and one's in C. So A is
Okay.
talking about like the direction of from domain to range. That's how we're thinking about these quote unquote pairs that Simona says. And in C, it's about that they have to have a unique elements in the domain have to have a unique element in the range. That's also something that Simona's missing that this diagram shows.
Gotcha. Okay. And then D and E are out, or we're still kind of thinking about those?
Okay. Well, I think E's not right because, like, Simona's definition is incomplete. So, Ms. Shalby, maybe like a sub reason is that she wants to give her like a specific show or a specific example, but that's not the main reason. Like a teacher would be called to like counter what the student's saying.
Sure.
But they need to correct the conception first before. Yeah, so I don't think that would be the main reason.
Okay.
Okay, wanted to refine her definition so it does not depend on a specific dependent. So Simona's not depending on a specific dependent or independent variable. My interpretation of D is that this would be like a student who can only define a function by showing a specific example and explaining it from that. That's what I thought D was saying, and that's not what Simona's doing. Wanted Simona to refine her definition so that it does not depend. Oh, or is it saying that like, yeah, is it saying that it's like not generalized and abstract? I don't know. Am I allowed to ask that? That's how I'm interpreting D.
Yeah.
It's not depend on. Because, she's saying an X and a Y. Is that what they mean by it? On a specific dependent or independent variable? I don't know, but I'm ruling it out.
Okay. It sounds like it's not entirely clear what was meant by this.
Yeah.
Okay. That's helpful.
Yeah.
Okay. Any other thoughts on this one?
Well, yeah, I'm just trying to think what's different about A than B. This is just saying the particular manner in which elements of the domain are mapped to elements in the range. This is saying that a function always maps elements in the domain with elements in the range. I guess, yeah, that's just the way we think about functions and the way we define it, but we could think about how elements in the range are mapped to elements in the domain. We just have to like adjust our definition. So it's not like we can't ever map elements in the range to the domain. We just don't define it in that way. So I'm going to rule out B.
Okay.
Okay. But when you adjusted it, when you said it differently without the word always, then I would have circled it.
Yeah, I think, what did I say? I said something like, point out that functions map elements in the domain onto elements in the range, or something like that.
Yeah, I agree with that. But the word always makes it seem like you couldn't interpret it the other way, which is possible.
Yeah.
It's not how we define functions.
Right. But like if you had an inverse function that was mapping the other direction, for instance. Okay.
Yeah.
Okay. Okay, cool. Oh. Keep hanging out in the same
nice.
space.
Great.
Okay.
Miss Garcia was preparing to teach her students about the range of a function. While planning, she sought out the formal definition found in her textbook. Given a function f with domain D, the range of f is that of all values y such that there exists an x with y equals f of x. Mrs. Garcia wants to offer a revised definition for her algebra students that is equivalent to the formal definition, but is probably for introducing the concept to children. What's the following? Oh, I would say A, B, and C.
Okay.
And not D, just because the language is really comes out of a function. I think that's just not very precise.
Okay, so E is out because this is like lacks precision.
Yeah.
Okay, so how were you thinking about the first three options?
Well, they're just three different ways to discuss range that are all related to A, what this definition is in. Yeah.
Okay.
Like, it's the output of the function. That's true. That's what this is saying, that we input a value for x and a value of y is output. Yeah, and all of them. So it's like just not using the word set. But okay, the range of a function is basically f of the domain. Yeah, the domain's the input, the range is the output. The range is all the possible y values. This is also, I use this. It's not like the most precise, but whatever. I think as long as you're teaching the other things too, it's fine to also talk about it. All the possible y values. Yeah.
So it's interesting. You said it's like it's not the most precise, but I mean, this is a thing that like is really common in teaching, right? Where there's this like really technical definition, and we need to talk about the ideas that are embedded in that definition in a way that is understandable by children, and doesn't set them up for misconceptions later, right?
Exactly.
So it's like there's this notion of equivalence that is like it's like mostly equivalent, and it's good enough for our purposes, something like that. You know,
right?
So is that kind of how you're thinking about all of these?
Exactly.
Is that like they all like are? Yeah. It's like good enough. Okay.
Right, because like if you just teach it is the range of all possible y values, maybe you're doing something where you're not using y as a variable, or like you're discussing inputs and outputs in like a real world situation. You might not think it's the range, but as long as you're also teaching other ways, I think C sort of discussing like one representation of range. Yeah.
Cool. Any other thoughts on that one?
Okay. During a class discussion, Padden suggests an alternative method for factoring quadratic equations. Should I read this?
Sure.
Okay, well, first I used the quadratic equation to find the roots. Then I just wrote x minus whatever the roots were as the factors. So, like for the example, we did x squared minus 7x plus 10. I just plugged everything in, then I simplified and got 5 and 2. So x minus 5 and x minus 2 is the factored form. Which of the following quadratic equation will this method produce? Okay, let me think for a second. So I believe this is about like which will produce like real answers versus like not real answers.
What do you mean by real?
Like imaginary
Oh,
versus
okay.
not imaginary. That's what I'm thinking. Okay, for which of the following? Oh, well, okay. He just did x minus the roots. That means hopefully he knows if it was a negative root and he did x minus, it'd be positive.
Mm-hmm.
But, oh, this, okay. Wait, I'm just gonna do some math for a second.
Do it.
Great. I think. Okay. Oh, okay.
So you just ruled out B?
Yeah, well, the discriminant would be negative, and okay, I believe that there, the roots would have to be imaginary.
What if Peyton knew
Yeah.
something about imaginary roots?
Yeah.
Would if he
Oh.
knew something about imaginary
Yeah.
roots, would that change how you were answering the question?
Then yes, it would. Because he would get roots behind them. Okay, honestly, I just don't remember if you can use this to find imaginary roots or not. Like if you could just, knowing that this was like, said to be negative 36, so it'd be 6i. If you could just plug that into this, and then you get your answer, that'd be right.
You mean if Peyton had done this and got
Yeah.
plus or minus 6i and then
Yeah.
just plug those in? Is that what you're saying?
Yeah. Yeah. Oh, yeah. I don't know.
So there's just a little bit of uncertainty about
Yeah.
how this would work with negative or with complex roots.
Right. Also, yeah. I'm also assuming if it was an irrational number, he would be able to figure it out too.
I think it's a fair assumption.
Yeah, yeah.
We'll just give him the
Yeah.
benefit of the doubt.
Right. So just like. Oh, wait, this wouldn't work if the roots were something, well, if it was something like this, but could you just do, would that be the same thing? I think it is.
You were asking if that would be the
Yeah.
same thing. What do you mean?
Wait, okay. I'm feeling this is great. I'm good for me to experience how students feel when they're taking tests. Because not all factored forms look like that, but I'm just wondering if you can convert it to look like this. Because if you had these equal to 0, they would be equivalent. And the whole point is when a root is when whatever you plug in for x equals 0. Okay, let me think one more thing and then we can move on from this. Okay, I could spend some more time thinking about this, but this is not some content I've thought about recently, so
Okay.
I'm feeling not very secure in my
Yeah.
knowledge.
Do
What would you like me to do? Like keep thinking about it?
you want to take a break from this one and then maybe come back to
Sure,
it later?
okay, yeah.
Okay, that sounds okay.
Great. Oh, I should read it out loud. Okay, Kip, a student in an Algebra 2 class, is working on the following test. Consider the following functions: f of x equals x squared plus 2x minus 2, and g of x equals 8x squared plus 8x minus 4. Which of the functions has a smaller minimum value on the domain -2 to 2? Kip generates the following two tables and decides that g is a smaller minimum value because -4 is less than -3. Okay. Which of the following statements is true? Okay, I know his strategy will sometimes not produce the correct answer, but
How do you know that?
because there could be some decimal.
What do you mean?
Well, okay, wait. Okay, I'm pretty sure, yeah, it's possible that there would be some value within, like some non-integer between -2 and 2, where it would produce a minimum that he's not seeing. Well, I mean, for example, this isn't the minimum. Like -4 isn't the minimum in this function.
Right.
The minimum is some value. I mean, it's still lower. I'm just wondering if this method, he would ever miss that fact. And I believe he would.
If it's helpful to
Yeah.
try to think of or generate a counterexample where you can
Yeah.
convince yourself that his method would fail.
Yeah. Well, yeah. Yeah, I think if it was like a really, like this type of function. versus a more shallow one. And then like these, yeah, definitely. There could be a parabola where,
Right.
I'm not sure if it's like, whatever, it's a more narrow parabola so that this value actually gets lower. Let's say these two things are the same, but like this is -4 and that's -4.
Right.
Or
Right.
maybe -3, whatever. So he would think this one's lower, but actually this one gets to -4,
Right.
so they have the same
Right.
minimum.
Right.
I want to think about if his, okay, so we can eliminate that his answer, strategy always produce a correct answer.
Yep. I thought it was raining.
Oh, no, it always says this. Will never produce a correct answer.